Hello. Today we're going to be talking about rational functions and their limits. If you don't remember what a rational function is anything where there's a variable in the denominator. The most common rational function is obviously just 1 over x. It's a simple one with a variable in the denominator. We're going to be looking at it when the limit approaches a number that makes the denominator undefined. All right. So for this one, 0 is what would make the denominator undefined. So we want to find out what's the limit as we're approaching 0, even though at 0 it would technically be an undefined answer. All right, so these would be places where we have asymptotes or holes at those undefined points. All right. Now, obviously, we're going to be working on ones with holes if we're going to have actual limits. An asymptote might create an undefined or non-existent limit. All right, so here's how we're going to find them. Our job is going to be to cancel out the variables for the denominator, and then we'll solve with that limit number being plugged in. So let's do a couple of examples. All right, first one here, looking at limit as x approaches 5. And again, if you make x a 5, the denominator becomes undefined, and you don't really know where at all the graph is, what it's doing at that point. So we would like to know what is actually happening at that point. So what we're going to do is we're going to do a little factoring. Oops, it's a little too thick of a line. Do a little factoring for the numerator, because the denominator looks kind of completed already. Nothing we can really do for the denominator. For the numerator, we can factor this. And I'd be looking for numbers that would multiply to make 15 and add or subtract to make 2. So 1 times 15, 3 times 5, it's going to be the 3 and the 5. Now, there's a hint as to what the 5 should be. The 5 is probably going to be negative to match with the one from the denominator. Because remember, when you add them, you're supposed to get negative 2. That's that middle number here. And when you add and subtract, you keep the sign from the bigger number. So that negative sign from that 2 came directly from our bigger number, which was the 5. Now, negative 5 and negative 3 together would make negative 8. But it's negative 5 and positive 3 together that would make negative 2. And now what can happen is that these denominator and the numerator both have a matching piece, the x minus 5s. And we are left with just x plus 3. So what we're allowed to do now is we can find the limit as x approaches 5 for our new function x plus 3. So just plug a 5 in and you get 8. Without that, we wouldn't have ever known where that limit was, because, again, the original equation would have given us an undefined limit, and it wouldn't have given us anything like 8. Let's try a little bit more awkward one. This one's going to require a little bit of expansion, making the problem look bigger, before we can make it look smaller. So I've got the x minus 2 in denominator. There's not much I can do there. But that numerator's got a parenthesis I can clean up. And if I square that binomial, I'll end up with 4x squared plus 4x plus 1, and then minus 25. Now I'll combine some like terms in that numerator. That 1 minus 25 part needs combined. And at this point, nothing's really canceling, so what I need to do now is I need to figure out how can I clean up the numerator a little bit more. And I see that they all have a factor of 4. All those numbers in the numerator can be divided by 4. So I'm going to factor out a common 4, leaving behind an x squared, an x, and a negative 6. If you're wondering where I got those from, I divided each of those numbers individually by 4. That's where I got the negative 6. Now, denominator is still x minus 2. Now, that numerator, I can do some more factoring. I can break that trinomial there down into 2 binomials. And I'm going to guess one of them is going to be x minus 2. So again, I'm looking for things that would multiply to make 6 and add to make 1 that we have in that middle term. So that's 1 times 6, 2 times 3. I think it's the 2 and the 3 that can subtract to make 6, which makes sense. When I do add the 2 and the 3, I get positive 1, so the bigger one was positive. That's the 3. Now, is it 3 plus 1 that makes... 3 plus 2 that would make that 1, or 3 minus 2? Well, it would be 3 minus 2. And as I expected, we're going to have a couple of terms that cancel, leaving us 4 and then x plus 3. Now at this point, we can go back to the start, rewrite this problem as the limit as x approaches 2 of 4 times x plus 3. Again, originally x equals 2 would have made a denominator that was undefined of 0. So now I plug that number in. 2 plus 3 is 5, times it by 4, and I get an answer of 20. This is your work today. Mostly just a review of factoring, obviously, is huge. And I tried to pick ones that were easily factorable. All right, good luck today.